Hi guys, welcome back. This is lesson 16, intro to organic chemistry. I love and hate this sub unit because on a college level it's a little bit difficult, but on a high school level it's actually really fun and it's really simple. It's actually really interesting. So let's go ahead and get started with what is organic chemistry. Organic chemistry is the chemistry study of carbon compounds such as carbohydrates, oxides, and carbides. Now, we are focusing on, in organic chemistry, we focus on the element of carbon because carbon has the ability to bond 4 times. Now, with it being bonded 4 times, and we're us dealing with carbon, which is a nonmetal, we are dealing with covalent bonds. We are no longer dealing with ionic bonds like we did in organic chemistry. We are now focusing on just covalent bonds. So we're sharing electrons when in organic chemistry. We're just sharing electrons. Now, the reason why organic chemistry is important is because it has to do with the study of life and all the chemical reactions related to it. This subject is very important if you're going into becoming a doctor, a veterinarian, dentist, pharmacologist, chemical engineering, and basically a chemistry teacher, right? So it's very important that you know this. So to start with organic chemistry, we need to talk about the compound that is associated with it, and that compound is hydrocarbons. Now, like the name says, hydrocarbon, it's obviously an organic material containing hydrogen and carbon. Now, because it contains carbon, we know that it's an organic material or organic molecule. Let me say that again. We know that it's an organic molecule because it contains carbon. Obviously, the name hydrocarbon breaks down hydrogen and carbon, so that's a way we can define it. Now, there's two types of hydrocarbons. There's saturated and unsaturated. Now, saturated hydrocarbons contain single bonds between the carbons, meaning there's the maximum amount of hydrogens attached to the carbon. We've saturated the amount of bonds that the carbon can have. This is why it is a saturated hydrocarbon. So as you can see in this image right here, this carbon, or all the carbons attached, are all bonded 4 times, even if they're bonded to another carbon. So there's no more bonds that can be made for any of the carbons. That is what makes it saturated. There's no more bonds being made for the carbon because it has its max amount of bonds. Now, unsaturated hydrocarbon means that we have at least one multiple bond within the carbon chain. So that could either be a double bond like you see right here, meaning we have 2 dash lines instead of one, or it could be a triple bond like we have over here where you have 3 dash lines instead of one once again. And with an unsaturated hydrocarbon, we know it's that because we are not maximizing the amount of bonds that the hydrogen and the carbon can make. Sorry, we are not maximizing the amount of bonds the carbon can make. So if we look over here, the carbon is bonded to the hydrogens, yes, but it's also bonded to the other carbon twice. There's a possibility for another bond if it breaks a double bond. So it's not being using its full potential. And over here in the triple bond, the carbon is attached to the hydrogen once, but it's attached to the other carbon 3 times, which is not allowing for the maximum amount of bonds to be made for that carbon. Now, the one thing about the bonds that are really helpful is if you have a single bond, that means you're only sharing 2 electrons. But if you have a double bond, you're sharing 4 electrons. And guess how many electrons you're sharing for a triple bond? Yes, that's 6 electrons. So each electrons, we share electrons by twos. And as we increase in our dash lines, that is multiplied. Now, there are a couple of hydrocarbons that we need to know, and these are the bases of our chemical molecules or of organic molecules. They are known as alkanes, alkenes, and alkynes. This is on table Q of your reference table. I know it's a little blurry and I apologize for that, right? Alkanes, alkenes, and alkynes. Now, the difference between these are obviously the endings. Alkanes ends in an ANES, alkenes ends in an ENES, and alkynes ends in a YNES, right? And they're also different because alkanes are all single bonds alone. Alkenes has a double bond, and alkynes have a triple bond. So if we look at the end of the name, which we have an example right here, ethane, we know that ethane, because it ends in an A and E, it is an alkane. Alkene, ethene, because it ends in an E and E, we know that's an alkene. Alkyne, because it ends in a Y and E, we know that's an alkyne. All right, alkene. Alkene. Right? Gets a little bit confusing saying all three. Now, based on that, I know what type of hydrocarbon I have. Now, sometimes they might ask you, okay, you know that it's an alkane, alkyne, alkene. How many carbons does it have? And this is when you're going to use table P of your reference table to help you. Now, once you figure out the amount of carbons you have in your compound, you can go ahead and put it in the general formula, and it'll tell you the molecular formula of your compound. So there's three types of formulas. There's molecular, structured, and condensed. The molecular formula is over here, and that's what we're going to be working with a little bit today. The structural formula we'll still work on in next week, and the condensed formula is going to be in between. But anytime you get confused with table Q, look at the bottom. It tells you what N is. So N is a number of carbons. Once you figure out your number of carbons, you can go ahead and find your molecular formula. So how do we go about naming? Today is going to be focused on naming. Now, we're not going to focus on the branch for right now, because branches, we'll get to that. We'll get to that next week. Today, we're going to focus on the chains. Now, a chain in chemistry is a straight line or a continuous line of carbons. And so we're going to only focus on the continuous lines of carbons. So that's what a chain is. So sometimes you might see, oh, there's a chain or the chain of carbons. That's what we're talking about. It's just a straight line of carbons that are continuous. Now, to name an alkane, I'm going to do this briefly. You're going to use table P to tell you how many carbons atoms you have. Then you're going to add the prefix ane at the bottom. Alkene, you're going to do the same thing. You're going to start numbering from the lowest carbon where the double bond is located, and it's also, you're going to use table P to tell you the prefix, and you're going to end your name with an ene. Alkyne, you're going to do once again, you're going to start numbering from the closest end of the triple bond, find out how many carbons you have, and then end your name in an ene. So the best way to practice is to go backwards. So that's what we're going to do. We're going to go a little bit backwards. Here we have table P and table Q once again. Table P tells you what our prefix is and the number of carbons we have. And then table Q will tell us what type of hydrocarbon we have. So, example right here, we have pentene, right? So we have our prefix as pent, and our suffix, our ending as ene. So I'm going to go back and look at table Q, P and Q to see which one pent. I'm going to start with the number of carbons, and then I'm going to end with the type of hydrocarbons. So what is pent? Well, if I look at table P, pent means I have 5 carbons, like a pentagon. So I have 5 carbons here. And let me look at table Q to see what type of hydrocarbon it is. Because it ends in an E and E, that means that it is an alkene. Okay, so that means it has a double bond. So I'm going to go ahead and write that right here. Okay, let's do another one. Now, I like to also put in parentheses, I'm working with a double bond. Okay, methane. Methane, which is in form of gas. Let's see, what is meth? And then ane. So let's focus on the number of carbons. So we go to table P, and we see that, where's meth? Where's meth? Meth is right here, and meth means that we have 1 carbon. All right. And then ane ends in an ane. That means it must be an. Which one of these ends in an ane? Well, alkane ends in an ane, so that means it is an alkane. And that means it only has a single bond. Okay. Okay, one more time. Butene. Butene. We're going to focus on bute and Y-N-E-ene. Let's go back to table P and Q. And let's look. Well, bute means four. We have four carbons. And then it ends in a Y-N-E. So let's go to table Q. Let's see which one of these ends in a Y-N-E. Alkenes used to end in a Y-N-E, so means our hydrocarbon is an alkene, and that is a triple bond. All right. And that is it for today, guys. All right, guys. So that is it, and that's what we're doing today. Let's do a quick summary real quickly. So we're working with organic chemistry, meaning we're focusing on carbon compounds. Carbon compounds, when we're dealing with hydrocarbons, we're dealing with organic molecules that only contain carbon and hydrogen. When we are talking about hydrocarbons, we are talking about two different types, saturated and unsaturated hydrocarbons. Saturated hydrocarbons contain single bonds only, and they're sharing two electrons within those single bonds. Unsaturated hydrocarbons contain multiple bonds, meaning it could be a double or triple bond, and that's either sharing 4 electrons or 6 electrons. It's unsaturated because it is not maximizing the amount of bonds that the carbon can make. Carbon can make 4 types of bonds. Now, this is the structural formula. Condensed formula just has all of the elements and the amount and the subscripts written together. And then molecular formula tells you how much your carbon and hydrogen you have. When it comes to organic chemistry, we use mostly structural formula and we use all three, but mostly the structural formula and the condensed formula. Molecular formula only happens when we have to name. Table Q is very important. Table Q tells us the types of hydrocarbons we have. So we have alkanes, alkenes, and alkyne. Alkanes only has single bonds. Alkenes have double bonds, and alkynes have triple bonds. This is our structural formulas right here, so we can see them how it looks. Now, if we had to name an alkane hydrocarbon, we will always end the name with an ANE. When we have to name an alkene hydrocarbon, we're going to end the name with an ENE. And alkene hydrocarbon, we're going to end it with a YNE. How do we know what the prefix is, how we're going to start the name? It depends on the number of carbons. So the number of carbons we can go and find on table P, and table P will tell us what we're going to start the name off as based on the number of carbons. So if I count 2 carbons, F, meaning what it is, F would be my prefix, and then whatever, if it's an alkane, alkene, alkyne, I'll end it with the suffix. And we did a couple of problems right here. See if you could do hexane. Tell me the type of hydrocarbon and the amount of carbons it has. And I will see you again on Friday or Monday, depending what it is. If you have any questions, please let me know. I am here to help you. Ask away. And I'll be available at 2 p.m. if you need any assistance with the work for today. Good job, and I will see you later, guys.